All right, welcome back. This is the last video of the 4, and we will be covering how to graph the polynomials that have zeros that are double zeros. Okay, so I said that if it's a double zero, then there's something very special about the behavior of the graph at that particular zero. All right, so let's take a look at this polynomial. Let's go ahead and sketch the graph of p of x, which equals negative 2x to the fourth minus x cubed plus 3x squared. Okay, so again, we will use the leading term to determine the left hand and right hand behavior. Okay, so this is our leading term. All right, so our left hand behavior, x goes towards negative, so we'll go ahead and plug in negative infinity into our leading term. Negative, so over here, negative to the fourth power will be positive. So we get negative 2 times positive infinity to the fourth. And so this will give us a negative result. Okay, so as x goes towards negative infinity, our graph will also go towards negative infinity. Our right-hand behavior, so x's go towards positive infinity, so I'm going to go ahead and plug in positive infinity. And positive to the fourth power is still positive. So here we still end up with a negative result. So here, as x goes towards positive infinity, our graph, our y values, go towards negative infinity. So on the left, it will drop, and on the right-hand side, it will also drop. Okay? All right, so let's go ahead and graph this. So on the left-hand side, it will drop, and on the right-hand side, it will drop. All right, let's go ahead and get the zeros, the real zeros. Okay, so we're going to go ahead and let y be 0, negative 2x to the fourth minus x cubed plus 3x squared. Okay, so here I am going to solve, and I noticed that they all have x squared in common. So I'm going to go ahead and factor out x squared. I'm also going to factor out negative x squared because I like my leading term to be positive here. Okay, so negative x squared. So I'll be left with positive 2x squared plus x and minus 3. Okay, and then here I have a quadratic trinomial, so I can go ahead and factor this. 2x times x to make x squared. I need positive and negative. I believe I did this last time. And this one will be positive, this one will be negative, and that will give me the positive one, x in the middle. Okay, so here I get negative x squared equals 0. 2x plus 3 equals 0. X minus 1 equals 0. So here x equals 0, and this one is a double zero. This one over here, subtract 3, divide by 2. So x equals to negative 1.5. And add 1. So x equals to 1. All right, so we have a 0 here. This one's a double zero, so I'm going to give it some sparkle. X equals negative 1.5. So we have that one there, and x equals 1. Okay, so here are our zeros. That one at 0 is a double zero. So here, before I graph this, let's get our extra points. Extra points. All right, -1. Let's choose -1 in between here. X equals -1. And let's pick something in between here. So 1/2, 0.5. Use a calculator. All right. All right. So when I plug in -1, I get -1 times 1 times -2. And that will give me +2. When I plug in 1/2, I get negative, and then I get 1/4, and then 4, and then -1/2. These cancel out. So this will give me +1/2. All right, so we have a point at -1, +2, 1/2, 1/2. Okay. All right, and so this is what's going to happen here. Let me zoom in. Oops. All right, so we know that the graph has to end going downward. You cannot cross, here's the thing, you cannot cross this more than this many times, okay? So these here, if it was single zeros, not double zero like this one, if you notice, they all go through. Let me show you previous graphs. Here are your single zeros, right? None of them are double zeros. And you'll see the graph goes through them, goes through it, goes through it. Okay, so whenever it's a single, whenever it's not a double zero, when it's not a double zero, your graph will go through that zero. Okay, so when it's not a double zero, these are not double zeros, your graph will go through it, and go through it. Okay, so over here, where we have this double zero, when it's a double zero, it will not go through. It will not go through. It turns out that double zeros are going to be maximums or minimums. They will be local extrema. Okay, so they're turning points. Okay, so what do we know so far? We know we have all of these points, and we know that the graph will fall on the left, and it should also fall on the right. Okay, so it's going to do this. It's falling on the left, and it should also fall on the right. Okay, and so what happens is, like I said, when it's a double zero, it turns out to be a local extrema. So it's going to do that. Okay, so it's a turning point. You don't go through it the way you go through this one, or you go through this one. You don't go through double zeros. You turn at them. Okay, so we knew that this had to happen, and we knew this had to happen. And so then we went ahead and created our graph based on what we understand. Okay, so this would be what the graph looks like. The point here is kind of blocking it, but it's basically doing this. And that double zero, which is right there, is a turning point. Okay, it's a local extrema. It's a minimum. Okay, that's what's happening there. Okay, so let's take a look at another one. Okay, so let's sketch the graph of p of x, which equals x cubed minus 2x squared minus 4x plus 8. All right, so we're going to use this for our end behavior. That's our leading term. So on the left-hand side, x is going towards negatives. So negative infinity to the third. Negative to the third power is negative. And then we have the infinity to the third. Okay, so this is going to be a negative result. So as x goes towards negatives, y goes towards negatives. Right-hand behavior. That's where the x's go towards positive infinity. Well, positive to the third power is still positive. So we get positive result. So as x goes towards positive infinity, y goes towards positive infinity. All right, so far we know that on the left-hand side, it will fall, and on the right-hand side, it will go up. All right, let's get our real zeros. Our real zeros are, well, let's see, x cubed minus 2x squared minus 4x plus 8. 0 equals 4 terms, so we're going to go ahead and factor by grouping. X squared times x minus 2, and then that's one group. Now I'll factor from this group, negative 4. Factor negative 4 out, x minus 2. Inside the parentheses matches, so I'm going to factor out x minus 2, and I'm left with x squared minus 4. That's difference of squares, so x minus 2 times x minus 2 times x plus 2. So right here we have a double zero. X equals 2 is a double zero. X equals negative 2. That's a single. All right, so x equals 2. That's a double zero. Give it some sparkle. X equals negative 2. Giving it some sparkle, that's just something I do, so don't be looking for the sparkle function on WebAssign. Trying to give your double zeros some sparkle. Okay. We need some extra points. Extra points. Let's see. We need to go in between here. Okay, so how about all three of these? Let's do 1, 0, and negative 1. Okay. 1, 0, negative 1. All right, when I plug in 1, I get negative 1. I get 3. I get negative 1. So that is 3. Okay. 1, 2, 3. So I have a point there. All right, 0. When I plug in 0, I get negative 2, negative 2, positive 2. And then I get positive 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1. When I plug in negative 1, I get negative 3. I get 1. I get negative 3, so that's 9. A little bit higher than that one. Okay, and I know this is a double zero. Okay, and that's my last zero. So I can see what, so remember here, it's going to be a turning point, and we need to turn and end up going up. So it's going to, we need to turn here and end up going upward. Okay. And there we go downward. You cannot cross the x-axis more than this many times. You can't touch it. Okay, so some people force it. It's like, okay, you just cross the x-axis and that's not even a 0. Okay, so make sure that if you're going to cross the x-axis or even touch it like here, that there is a 0 here. Okay, it should show up here. If it doesn't show up here, you shouldn't be crossing there. So some people will force this because they don't understand that this is not a turning point, that this is a turning point, and they end up crossing through it. And they're like, oh, I got to end up going upward. So then they'll force their graph to cross the x-axis at some unknown location that is not a 0. Okay, if it's not part of your list, you shouldn't be crossing. Okay, so that's how you get this graph. So just in general, okay, so here are some notes. Note, so if you have double zeros, or even multiplicity, so whether you have like x squared or x to the 4th, right? So at x equals 0, this is a double 0. X equals 0, this has multiplicity 4. So, and even if it's x to the 6th, right, then x equals 0 is a 0, and this has multiplicity 6. Okay, so in general, if it's a double 0 or a multiplicity that's an even number, then 0 is a turning point. It's a max or min, a turning point. Okay. And then if it's odd, so we do have multiplicity that's not even. We could have a multiplicity like 3 or 5. Okay. And so let's put another note here. Zeros with odd multiplicity, they have a different behavior. So odd multiplicity, so like multiplicity 3, multiplicity 5, multiplicity 7, multiplicity 9. Okay. So like this. If you have like x cubed equals 0, then x equals 0, and it has multiplicity 3. And if you have like x to the 5th, then x equals 0, and this has multiplicity 5. Okay, that's what I mean by odd multiplicity. Okay, so here we know that it will be a turning point. So if you have that is a 0, it could be a turning point like this or like this. Okay, it could be one way or the other. Okay, when it's odd multiplicity, okay, then what happens is if this is where your 0 is, it's not going to be a turning point, but it has this sort of x cubed behavior. Okay, it could have that one or it could go the other direction. But it does have that behavior right very close to that point. Okay. All right. So let me give you an example. If you have this here, p of x equals x to the fourth times x minus 2 cubed times x plus 1 squared. All right, so x equals 0. That is multiplicity 4. X equals 2. That is multiplicity 3. And x equals negative 1. That is multiplicity 2. Okay, so this is what the graph would look like. All right, so 0, they all get sparkles, right? 2 and negative 1. All right, so this one, negative 1. This one is even. 0 is even. And 2 is odd. Okay? And so it ends up doing this. Evens are turnarounds. That's a turnaround. And then odds will have that sort of x cubed graph. Do you see? Do you see that right in here? That sort of, can't really tell, but if I zoom in and you only look at that part, this looks like the x cubed graph. Okay. And these guys are turning points because they're even. Okay. Hopefully that makes sense. If you have any questions while you're doing your homework or while you were watching the videos, make sure you text me. And some of you guys are making use of texting me questions with your pictures of the problems you're doing. That's fantastic. So these two chapters, chapter 2 and chapter 3, a little more abstract. So if you have questions, if you want me to do some more examples of anything, make sure you text me or email me. All right, so that is it. I will see you next time.